Okay, y'all, so 8.1 deals with polynomial functions. So before I get into the college algebra part of this, I'm going to review y'all a little bit about polynomials, okay? So this will be a review. So I'm just going to put a polynomial up here. Y'all remember, that's what poly means, many. So a polynomial is something that contains many terms, okay? It can be as small as one term up to infinitely many terms, okay? So I need to get y'all familiar with some terms in this section. We're going to look at what we call a leading term. We'll look at the leading coefficient. And then we'll learn about the degree. And then I'll show you something that you're going to need for your support on the names of these polynomials. So I'll go through some of the names of some of the polynomials you'll see in the support, okay? So this is a polynomial. This one has 4 terms. Terms are separated by subtraction and addition. So the leading term of a polynomial is the term that contains the highest exponent. So for this example, the leading term is going to be the 3x to the 5th. Okay, so remember, the term is the whole thing, the number and the exponent and the variable. Now, coefficients, those are the numbers in front of the variables. So the leading coefficient would be the number that's in front of our leading term. So the leading coefficient would be the 3. Now remember this, if we have no number in front of that variable, you got to treat it like a 1, okay? Now, the degree of the polynomial, that's equal to the highest exponent of that polynomial. So the highest exponent is a 5, so that makes the degree of 5 for this one, okay? So the leading term, which is determined by the highest exponent, okay? So I'm going to give you a few names of some polynomials you'll see in the support, okay? If it has one term, then it's what we call a linear. Oh, hang on. We didn't want that 2 there. If it's just an x term without any exponents, it's linear. My bad. Now I wanted to write my x squared next. If it's an x squared term, the x squared term, we call those quadratic, just like them quadratic graphs we were drawing. If it's got a cube in it, then those ones we actually call cubic. And we have one that contains an exponent of 4. If you have an exponent of 4, those are what we call quartic. Now, the last one you need to know. if it equals some number, A can be any number, but if there's not a variable with it and it's just a number, then we call them a constant polynomial. So if these right here are the leading terms of our polynomial, and then we have other terms after it, as long as these are our leading terms, they're going to determine the names you get out of those. Okay. All right, y'all. So that's enough of that review. So I just wanted to bring back a few polynomials for you. So let me see what we got in chat. So yeah, constant is just a real number. So they might have something like P of X equals 5. That would just be a constant, because remember on that piecewise function y'all were doing, and it had some of the X values, and then it might have had just a 5 for the answer. It didn't have the variable, so that would have been a constant one, okay? And remember, what did the constant graphs do? Those were the ones that went straight across like a horizontal line, right? When y'all was doing the intervals. Okay. All righty, so let's get into the college algebra part of this. So we're going to look at what we call end behavior. End behavior is what's happening to our graphs as those x's head out towards negative infinity and positive infinity. So we can tell by the degree of the polynomial and by the lead coefficient sign of the polynomial what the end behavior is going to do. So we're going to make a chart based on the degree. So across the top, we'll have the degree. So in our chart, the degree can either be even or odd. So we're going to make 2 columns. First column will be even. Our second column will be odd. Now, we also look at the lead coefficient. So for my rows over here, our lead coefficient can have 2 signs. It could be a positive or it could be a negative. So y'all, we're going to make this into a T-chart here. And we'll get 4 pictures of what these graphs look like, okay? If it's an even degree, like those x squared graphs we drew, and the lead coefficient was positive, like the A was, that means that our graph will try to head towards positive infinity as we go out on those x's in each direction. And y'all have been drawing a lot of parabolas here lately, and that was true on those, right? All righty. If it's an even degree and my lead coefficient is negative, guess what? It's going to flip that graph over the x-axis. And at both ends, it's going to want to head towards negative infinity. Okay. Now, the reason they got gaps in between these is depending on how large that degree is, we'll learn later, determines how many times these graphs turn inside before they head towards those infinities, okay? Now, if your degree is odd, so my largest exponent is odd, then my graphs are going to want to try to head uphill, left to right. And once again, they leave gaps in here for the number of turns that the higher exponents will do, okay? And then finally, guess what? If it's an odd degree and we have a negative lead coefficient. It's going to flip that one over to x-axis, and it's going to look like it's heading downhill, left to right. So what we're going to do on these examples, I'm going to give you a polynomial, and based on what we're given, we need to determine if it's going to be one of these four pictures, okay? Now, for y'all to help me, I'm going to label these A, B, C, and D. That way, when y'all figure out which picture it is, y'all can just tell me A, B, C, or D on these, okay? So y'all, for these examples, we're going to select the sketch that matches the end behavior. Of the function. Okay, so for our number one, they're giving us f of x equals square root of 5x to the third plus 5x squared minus 3x plus 3. So y'all want me to do one and then I'll let y'all do, say, the next two, or y'all got this one? So I'm seeing a B up there. So, oh, look at that. That is a good job. It is definitely B. Because y'all look here. My degree is 3, which is odd. That square root of 5 is positive. So positive and odd is definitely going to go uphill, left to right. All right, so y'all have that chart, right? Because I'm about to do away with this page and just start writing my problems down. All right, try this one. P of x equals negative pi x to the 6th plus x to the 5th minus x to the 4th minus the x plus 1. So, A, B, C, D. Oh, y'all, what am I getting? I'm getting some, I got a C and a D. So let's see who's right. All right, so look here. My degree is 6 on this one. Because my 6 is, okay, so we're going to go with, it looks like C then, right? Because that is positive. My lead coefficient is a negative pi. And they're just trying to throw y'all a curveball with that pi in there. But yeah, when it was even and negative, it went downhill on both, which was C. All right, y'all, f of x equals negative 4.5 x to the 4th plus x to the 6th plus 0.8 x to the 7th. All right, if I'm getting you on this, and let's see, I'm seeing a B. And Zach, you don't want to stay on there. So let's see. So good job, because you notice that they put this out of order. The degree is the highest exponent, so good job. It is definitely odd. And then that 0.8 is positive. So odd and positive is definitely RB. So y'all watch for that. They're going to put them out of order once they think y'all got the idea of them, okay? All right, so we're going to cover a lot of different subjects tonight. So the next thing we look at is what we call using substitution to determine if a number is a zero. So using substitution to determine if a number is a zero of a polynomial. Remember, zeros are also what we consider solutions of these polynomials. Zeros are also equal to the x-intercepts, okay? So, first thing you're going to do, plug the number into the polynomial for the variable. Oh, y'all, once I plug my numbers into all them variables, I'm then going to use order of operations and evaluate that polynomial. So here's the thing. If it's a zero of that polynomial, then the result will be zero. So if the result equals zero, then that number is a zero. Okay, so I'll tell y'all this. Today in these problems, we're going to use substitution to determine if a number is a zero. Next week, when we hit section 8.4, and I think even in 8.3, we're going to learn about synthetic division. That's another way I can tell if numbers are zeros, okay? And y'all are going to love synthetic division. All right, so they're giving us one problem here to work this kind of stuff out on, okay? So this one wants me to use substitution to determine whether 5 is a zero of f of x equals x to the third minus 12x squared plus 14x plus 105. So basically what this is telling me, since this is my polynomial and they want me to check for 5, they really want me to figure out what is f of 5, since 5 is what I'm putting in for my x's. So y'all, that's going to give us what? A 5 to the third minus 12 times 5 squared plus 14 times 5 plus 105. So it's all about order of operations on these. We just got to work this right half and see whether we come up with a zero or anything else. So I'm going to work it by hand, but y'all at this point, you can throw that right in that calculator, okay? You got exponents, you got parentheses. It'll knock that out quick. So by hand, I'm doing these exponents first. I'm going to cube that 5, and then I'm going to square that 5. So 5 times 5 times 5 gives us 125. Minus 12 times whatever we get when we do 5 squared. Well, 5 times 5 is 25. And then I'm just going to bring everything else down. So all I did was my exponents. Now I'm going to go left to right and multiply. So bring down that 125. Right here, we got 12 times 25. That's going to be minus 300. Plus, right here, 14 times 5 is 70. And then plus my 105. Oh, y'all, here we go. 125 minus 300 is a negative 175. Negative 175 plus 70 is a negative 105. Negative 105 plus 105 gives us a big 0. So guess what? Since we got a 0 remainder, that means yes, 5 is a 0 of that polynomial. Okay, y'all, so let's learn a new word. Our new word will now be multiplicity. Hey, y'all, so for us, multiplicity simply means how many times a factor occurs in a polynomial. So it's how many times a factor occurs in a polynomial. When factors are written using parentheses, then the multiplicity is equal to the exponent. But let me ask y'all this. Say I got something factored and it does not have an exponent outside those parentheses. Do y'all know what we would make that exponent equal?
No.
So let me show you what I'm talking about. Oh yeah, it's the 1 definitely. So remember, if I'm squaring stuff, I would write it twice. But y'all, if those parentheses do not have an exponent, we got to treat it like a 1. All right, so watch this. Here we go. We're now going to find zeros and state the multiplicity. So find zeros of the polynomial and multiplicities. So these start around number 6. I'm going to keep my number and sort of going along y'all's homework here. So y'all got this. F of x equals x squared minus 4 to the 5th power. Y'all, when I write something like this 5 right here really means that we would write this thing out 5 times if we were going to FOIL it or do something like that, okay? So this part is our factor. This part is our multiplicity, okay? So that is the exponent that is sitting outside of my parentheses. So what we really got to do here is solve this so we can find the zeros. And remember, to find the zeros, I'm going to set it equal to 0. Right, stuff y'all were doing when y'all was using the quad formula, y'all were finding zeros using the quad. Y'all were factoring to find zeros. Now I'm going to show you a third way to find zeros when you just got two terms like this. Now, y'all, I'm not going to lie. On the quad, if you use the quad program on my calculator, A is 1, since there's not a number in front of the x squared. There's not an x in the middle, so B would be 0, and then C would be -4. Okay, so quadratic formula in the calculator would solve that. But I want to show y'all another way to solve it that's called taking square roots. So I'm going to solve this by taking square roots. In order to take square roots, you got to get the x squared term on one side by itself. So we need to move the 4 over here by adding. Now, I got my x squared term by itself. To turn an x squared term into an x, I take square roots of both sides. So I come in here and take the square root of the x squared. Now, I'm going to take the square root of that 4, but anytime we take the square root of a number, we need to put a plus or minus in front of that. Because remember, 2 times 2 equals 4. -2 times -2 equals 4. So we got to look at both answers when you're doing equations. Also, since the exponent on that x is a 2, that tells me I got to get 2 answers on this, okay? All right, so watch this. Square root of x squared is x. This gives me a plus or minus 2. So my zeros are 2 and -2. Each has multiplicity of 5. So 5, because that's the number of times this factor occurs. And then the zeros are 2 and -2 because that's what the factor gave me when I set it equal to 0. See, all these aren't too bad. You just gotta get used to looking at the exponents for the multiplicity and being able to solve these for those zeros, okay? And y'all, like I said, quadratic formula will spit these answers out quick. All right, so I'm sort of going to have y'all, I'll show you what y'all going to help me fill in these blanks in a second on this one. So they're giving us f of x equals x to the 4th, x minus 2 squared, and then x plus 8. So we're going to find our zeros in multiplicity, but when we answer it, they want to know the smallest zero is blank with multiplicity blank. The middle zero is blank with multiplicity blank. The largest zero is blank with multiplicity blank. So they're sort of picky when we answer the actual questions. So we're going to find our zeros and our multiplicity when we fill this chart out, okay? So to find the zeros, you got an x to the 4th. That means we take this factor x, set x equal to 0. The second one, we take what's in the parentheses, the x minus 2 factor, set it equal to 0. And then the last factor, the x plus 8, we set it equal to 0. So when you got these single x's like this, they're always going to be 0 for their zeros, okay? The other two I got to solve because they got adding and subtracting. We all add 2 to this one. I get x equals 2, subtract 8 from the last, and get me a negative 8. So y'all, first line for y'all. The smallest zero is blank with a multiplicity of blank. What are we putting? Oh, okay. So I got everybody on that one. So y'all tell me, is 0 the smallest number on there? Uh-oh, Unai got it, I think. She got a negative 8, which is the smallest zero, is negative 8. And it had a multiplicity of, so y'all, what we say, since that negative 8 come from this factor, what's that exponent there? Because I do not see a number. So there you go. It is a 1 sitting there. So the smallest zero is negative 8 with that multiplicity of 1. All right, so who wants the next one? The middle zero is blank with a multiplicity blank. So which, okay, so I got a 0 and a 4. I'm going to take that. Good job. So the middle zero is 0, multiplicity 4. So that means my largest zero was the 2, and it had a multiplicity of 2. There you go. So y'all, although they had you finding zeros, they're a little picky on the small, medium, and large on that one, okay? All right, so moving on to 8. Same thing here. We got f of x equals negative 5 times x minus 5 squared times x plus 2 to the third times x4 at the back. All right, y'all, so realize that's a factor, that's a factor, that's a factor, but this negative 5 is not a factor. It's just a constant term they threw in here. We cannot set x negative 5 equal to 0. That would be a false statement. So anytime you got a number by itself and you're finding zeros, cross that thing out because it is not needed, okay? So we do have 3 variables, and that's what we're worried about, our variables. So we're going to come in and set all of our variables equal to 0. And y'all, there's that single x again, which automatically is going to be 0, okay? So now let me show you how they want these answers. They say the 0, 5 has a multiplicity blank. Blank is a 0 of multiplicity 3. Then they say the remaining 0 is blank. It has multiplicity blank. All right, so we might as well solve these real quick, and then we'll be able to fill out these answers. So the first one, I'm going to add to 5. Get x equals 5. Second one, we're going to subtract 2 and get x is a negative 2. My third one was already solved, x equals 0. So y'all answer this. The 0, 5 has a multiplicity of what? All right, so y'all are banging away on them 2s, and that's a good job. Definitely 2. All right, let's see what's going next. Blank is a 0 of multiplicity 3. Well, you're quick now. -2 zooming everywhere. Okay, good job. So that means the remaining 0 is blank with a multiplicity blank. Okay, 0 4s. That's good. There we go. You know, that stuff's not too bad. It's mainly getting used to that lingo they use, okay? What is multiplicity? What is zeros? All that fun stuff. All right, so guess what? They're not going to give us every polynomial factored, unfortunately, okay? So we're still finding zeros and their multiplicity. But y'all look at this. They're giving me f of x equals x to the 3rd minus 5x squared minus an x plus 5. I got 4 terms sitting here, not factored. So we're going to have to factor this. So have y'all ever heard of what we call factor by grouping? If you had either foundations of algebra or transitional algebra, that's probably the way they taught y'all to factor. I'm going to go through this one sort of slow so this can bring back y'all's memories, okay? So to factor by grouping, the first thing I got to do is make 2 groups. So I'm going to group the first 2 terms together and my second 2 terms together. Those are my 2 groups, okay? It's always the first 2 and then the last 2. Y'all, the second thing you want to do when you factor by grouping, you want to factor out the GCF of each group. Now, the second GCF has the same sign as the third term. So now we're going to factor out the GCF. So the GCF is the factor that both of these have in common. It's the largest factor, okay? So here you got 3 x's. Here you got a -5 with 2 x's. So the most that these 2 have in common would be an x squared. Then I'm just going to write GCF by that so that we know that's the GCF. So y'all, you pull out these GCFs and you follow that with parentheses. Now, to get what goes inside the parentheses, we take both of these terms and divide them out by that x squared. So if you had an x to the 3rd and you're dividing by x squared, subtract exponents. 3 minus 2 would leave me 1x. Then I got my negative. That's going to stay negative since I'm dividing by positive. Now, A 5x squared divided by x squared, well, on the variables, 2 minus 2 is 0. So that means the variable cancels out, and all that's left is the 5. Okay, so basically I took the x3 divided by x squared to get that. I took the negative 5x squared divided by x squared to get that. Now, we said right here that the second GCF has the same sign as the third term. My third term is negative, so my second GCF will be negative. So y'all, I'm sort of stuck here. What would be the GCF between an X and a 5? And I will say they do have something in common. Oh, okay, I see it right there. -1. You at least got to pull out a 1 from these factors, okay? So we would actually put our -1 here. Now, to get what's going in these parentheses, we would take both of these terms and divide by -1. And y'all, all that -1 basically is going to do is change their signs, right? Negative x divided by -1 makes that an x. 5 divided by -1 makes that a -5. So I did negative x divided by -1 to get that. 5 divided by -1, get that. All right, so we're almost to the point where we got this factor. So what we do now, we're going to draw 2 sets of parentheses for this step. In one of these parentheses, we put what's inside here. You see that both of these parentheses match. So we're basically going to factor out that x minus 5 as a GCF in a way, because it's common between both of these big terms. So y'all, check this out. If we factor these x minus 5s out as a GCF, the x squared minus 1 becomes the second parentheses. Okay, so inside the parentheses becomes one factor. The outside becomes the second factor. Now, we've got that factored. We're going to set all this equal to 0 so we can find our zeros, okay? So, we're going to take both these factors, set them equal to 0. Now, let me ask y'all this. What's the multiplicity of both of these factors? Oh, y'all, let me get y'all answer. Oh, yeah, remember, if there's not exponents on these, it is definitely like there's ones out there, okay? So treat any hidden exponents as a 1 when you got your factors. Now, we will get them numbers you're saying. I'm going to get 5, but remember, 5 is actually a 0 of it, not its multiplicity, okay? Now, y'all, this one, I'm going to solve that by adding 1 like I showed you a while ago. X squared equals 1. And then I'm going to take that square root of both sides. Remember, that's going to be a plus or minus square root of 1, so that we get x equals a positive or -1. So our zeros are going to be 5, 1, -1. Each has a multiplicity of 1. So y'all, do y'all want to learn if so? Are any of y'all struggling with this factor by grouping? Because I can show you another way on my calculator that I can knock that thing out quick. All right, so watch this. So, and you'll have this video. So watch what I do on this calculator, okay? So I'm going to go up here to new share and get my calculator. So the first thing I'm going to do is go to y equals, and I'm going to clear that out. And I'm going to put that polynomial up here. Remember, I had x to the third and then I had what, minus 5x squared minus the x plus a 5. So watch this. I'm about to find these zeros. I'm going to go over here. Now I'll show you on the graph real quick. Remember, that's a cube, so it's going to go sort of uphill left to right with some turns in it. Now, if you can see down further, this left side heads down towards negative infinity. That right side heads up towards positive infinity. But y'all, all these zeros are these points where this graph is crossing that x-axis. So don't it look like that first one's crossing at -1? That second one's crossing at +1. And then let's see, 2, 3, 4. This one looks like it's sitting at 5. So those 3 places where it crossed is those 3 zeros I just found. Now watch this. If I go to second graph, I'm looking for any of these x's that have y values of 0. So look here, my first 0 for the y is at x equals -1. That second 0 over here for the y. So let me show you what I'm looking at. I'm going to highlight what I'm looking at. So there's that first 0. Whoops, one back. There's the first 0, and it has the x of -1. I go down to the second 0, it has the x of +1. And then my third 0 has the x value of 5. So by graphing them, you can actually find those zeros, okay? Now I'm going to do one more of those by hand, and I'll show you how I would do it on my calculator. So this would be like y'all's number 10. I got f of x equals 6x to the, let's see, 6x to the third minus x squared minus 96x plus 16. So remember, grouping it, put the first 2 and the second 2. We're factoring out GCFs from each of these. And I do know the second GCF will be negative because my third term was negative. So y'all, once again, we can factor out an x squared on these. So factor out the x squared, that's my GCF. So 6x to the third divided by that x squared leaves us a 6x minus, oh no, look at that. X squared divided by x squared is 1. All right, we said the second GCF was negative. And y'all, actually, their GCF is going to be 16. 16 goes into itself once, and then 16 goes into 96 6 times, okay? So theirs is going to be a -16. So a -96x divided by -16 is going to make that a 6x. And then 16 divided by -16 makes that a -1. So remember, our parentheses have to match 100%. So now that we got these parentheses matching, we're going to place our factors into the parentheses here. So remember, I said it was the inside, which is the 6x minus 1, times the outside, which is the x squared minus 16. So this is now factored. We're going to set this equal to 0. All right, y'all, here we go. Let's solve for our zeros. Set both the factors equal to 0. So I'm going to solve the first one by adding 1. I get 6x equals 1, divided by 6. X equals a 1/6. The second one, I'm going to add 16 and take square roots. But remember, you could use the program for that. 1, 0, negative 16 on the quad, okay? That'd be your ABC. All right, x squared equals 16. Take those square roots. That's going to be a plus or minus. Square root of 16 on the right side. So that x gives me a plus or minus 4. So our zeros are going to be 1/6, 4, and negative 4. So what's each's multiplicity? So y'all are saying, so yes, definitely 1/6 is a 0. And then each one of them had a multiplicity of 1. Good job. So yeah, unfortunately, sometimes there's fractional zeros. Now, y'all, I'm going to show y'all a trick. So pay attention what I do on this calculator, because those X's are not going to show you those 1/6, okay? So let me show you how to get them kind of answers on that graph. So let me see. In Math Lab, would we write it as a decimal? No, they would want you to put 1/6 on that one. They got that little fraction tabby thing y'all use when you click in the answer blank. All right, so I'm gonna clear this one. I'm gonna go to y equals and clear that. Okay, so this one was 6x to the third. Minus the x squared. Minus 96x. Plus 16. So y'all, let me show you what would happen on the graph. So you would click graph. So this one looks like it's at -4 on the far left side, 1, 2, 3, 4 over. On the far right side looks like it's at +4. But y'all, this first one, it's not going through the points. It's not going through 0, and it's not going through the 1. So that's the one that's the fraction. So watch this. When I go to second table for my values, let me go up here to -4 real quick. At -4, I got a y value of 0. When you click down through here, +4, you got a y value of 0. We're not catching that fraction yet. So let me show you what I do to those. I go to second window because I want this table set part. Now we're going to go into table set. Now watch this. I'm going to arrow down. You see the triangle in front of that TBL? The triangle means the change in our table values. How do we want them to change? So watch this. I'm going to arrow down to the table set. Now, do y'all remember how mine started out with a 6x to the third? Since 6 is the first number, we need to write this as 1/6. So watch this. I'm going to go 1 divided by 6. This is now going to split my table up into increments of 6. So check this out. If you had a 2x third in front of yours, your table would be on the delta table would be 1/2. If you had a 5x to the third, you would make this 1/5. So put a 1 over whatever your first number is. Now watch this. I'm going to go back to my table by hitting second graph. Look, it's going by 6. So we know there wasn't nothing to the left. I need to get around where that 0 was, right? So I'm coming down, coming down. I'm going to move these X's until I got so let me highlight the Y's. So I'm going to go over here on my Y values and start highlighting. I need to find a 0. Up, look at that. I got a 0 at 0.16667. If you punch that into the calculator over here, remember it don't want decimals. So if you punch that, clear this screen. Oh, I want to quit the screen, so second mode. If you punch in 0.1666666, I forgot how many sixes were there. It should turn that into a, oh, I didn't have enough sixes. It's rounding off, so let me see. Let me put enough sixes there. Because it's rounding off that 7, so we need to get a lot of sixes in here. And then we try to turn that into a fraction. Let's see. Okay, I got enough sixes in it. But look what it gives me, 1/6. Okay. So remember, when you see a 1.666 and they rounded it to the 7, that's like them sixes go on forever and ever. Okay. Now, most of them ain't as tricky as that 1/6. Like if you had 1/5, that'd be 0.2. It'd turn that back into a fraction quick. So did that make sense how I was getting to that delta change for that table? All righty. So y'all, by hand, we can find these zeros, like I said, or graph them, okay? Just remember, when you graph them, look at that first number so you know what to make your changes, okay? All right, so now we got a couple more definitions, and this will finish out 8.1, and then we'll be able to look at 8.2. So I'm going to draw me a graph here. So sometimes when we're graphing, a graph will come down at the 0, and then it'll turn up. When that graph comes down and touches that x-axis where the 0 is located and turns back up, we say that this is tangent to the x-axis. So the x-axis is serving as a tangent line to the bottom of that curve there, okay? Now, for that to happen, the degree must be even for that factor. So if you got something like x plus 5 squared, well, that plus 5, when you solve it, would give you a -5 as a 0. And since it's an even exponent of 2, that graph is just going to come down, touch the x, and go back up. Now, say my graph curved around and my next 0 was on the right side. But notice, this time it passed all the way through the x-axis. So this one passes through the x-axis. And y'all, guess what? Those degrees must be on. for that factor. So factors with an even degree come down and they touch the x-axis. Factors with an odd degree pass right through it, okay? So let me give y'all a true or false on what I just told you. And then we'll look at the 8-2. 8-2 is pretty small, okay? Most of 8-2 we can do with the chart I gave y'all at the beginning of 8-1 with the end behavior. So for this one, if P of X equals X minus 6 to the third times X plus 2 to the 10th, then the graph is tangent to the x-axis at -2, 0. What y'all think, true or false? At the x-intercept of -2, 0, is that tangent, which means it's coming down, touching the line, and going off? All right, so let me see. All right, I'm seeing an F, so let's see. So remember, to get -2, 0, it came from this factor. Remember, the zeros and the factors are always opposite in sign. So it came from this factor. And y'all look at that, it's got an even exponent. So remember up here, we said what happens when they have even exponents? They are actually tangent to that x-axis. So this one said, there you go. This one said tangent, so that is definitely true. All right, y'all, moving on. So you'll have 2 questions doing that. They're not bad. Just look at these degrees and see if they're even or odd. All right, y'all. So 8.2, graphing polynomial functions. Now, we're not actually going to graph them. They're going to give us pictures to pick out of. But before we get to that, we can use the degree of a polynomial. We can use the degree to determine how many is the maximum number of zeros. How many is the maximum number of x-intercepts? And then what would be the maximum number of terms for that polynomial? Now, they don't have to do the maximum number, but that is the highest they could turn, okay? So to determine how many maximum zeros, the maximum zeros of a polynomial is equal to the degree. And y'all remember, the degree is the highest exponent. Okay, then maximum x-intercepts. But if y'all remember, we taught y'all back in material for test 2 that x-intercepts and zeros were the exact same thing. The zeros were equal to the x values of those x-intercepts. So if the zeros is equal to the degree, the maximum x-intercepts is equal to the degree. Which once again is my highest exponent. Then maximum number of terms. Well, y'all, guess what? That's actually not equal to the degree. It's equal to the degree minus 1. So this would be the degree minus 1. So highest exponent, highest exponent, highest exponent minus 1. So we're going to find the maximum zeros, maximum x-intercepts, and the max terms. F of x equals x to the 6th minus x to the 3rd plus 4. So y'all, I need the max zeros. I'll need the max intercepts for the x. And then I'm going to need the max terms. So all right, so I'm going to do this one, and then I'll let y'all knock out my next one. So for me, my degree is a 6. That's my highest exponent, which means my maximum zeros is equal to the 6. My maximum x-intercepts is equal to the 6. But remember, my terms are minus 1. So 6 minus 1 would give me 5. All right, so let me see. This one's for y'all. So let's see. I'll start y'all out sort of mild. F of x is a x to the 12 minus 4x to the 4th plus a 9x minus 5. So y'all tell me the maximum zeros, maximum x-intercepts, and the maximum terms. So let me see. Whoa, let me get my eyes up here. That looks like 12, 12, 11. That sounds good to me, right? Highest exponent is a 12, so that's automatically those two answers. And then subtract 1, get me 11. All right, y'all. So moving on. F of x equals negative 9x minus x to the 6th. So I'm going to need maximum zeros, maximum x-intercepts, and maximum terms. So well, y'all quick. So good job. It's out of order, but that highest exponent is a 6. So that's going to be 6, 0, 6 intercepts, and 5 terms. All right, y'all. So I'm going to show y'all on MathLab what the rest of these graphs look like. So this won't take long. So let me go to my MathLab. All right, so let me move this out of my way. So they're going to give you a function. This one has f of x equals 1/4 x squared minus 6. They want us to use our leading term. That's the box we drew a while ago with the even and odd degrees. plus or minus lead coefficients. So knowing that, let me move this out of my way real quick. Which graph would y'all choose for this answer, knowing that that is a degree 2, which is even, and a positive 1/4 for that lead coefficient? So y'all remember y'all's chart? I'm even and positive. So we went with C on that. So let's see. I can't see, but let me move that real quick. So even, so y'all said C, right? So C is good job. So let me show y'all one more what they might do. So how about this one? Y'all got an x to the 5th minus x4 plus x squared plus 14. Which graph would y'all pick for that? So I'm saying B's and I'm saying C's. So let me go see what we got to do. So odd degree, and it is positive. So for odd and positive, that's going to go uphill left to right. And our only graph going uphill left to right is the C. So see, they're going to be distinctive answers. This one's going downhill for A. B looks like the one that was even and flipped upside down and so on, okay? So one more of these and then I'll be done with y'all. Well, that's the same one, right? So, yeah, we want to move on. Now, notice on this one, even exponent, positive 1. It's going to go uphill on both sides. But y'all look, A and C both go uphill. So yeah, y'all be careful because both of these go uphill. So what you got to do is look at this -17. -17 is the y-intercept when it's that last number. So you would want to zoom these graphs up and see which one looked like it was crossing at a 17. So they're telling us this goes, you see under this graph, it says all graphs -5 to 5, -30 to 70. Let me show y'all a trick on that calculator. We can put this on a calculator and set the window exactly how they have it. So let me write that problem down real quick. And we're going to set our window exactly like they got. -5, 5. And then they got what? -30, 70. So if you want it to look exactly like theirs, we're going to go to our calculator. So watch this. I'm going to show y'all how to figure that one out. Go to my calculator. I'm going to clear what I got on here. Well, I'm going to go to y equals. Clear that. I'm going to put in that polynomial, x to the 4th minus 2x third plus 7x squared plus x minus 17. Now, what they was giving us in them brackets, that -5, 5, 30, 70, was the window settings. So to set your window, you see the button that actually says window, we're going to click that. So what that is, they give you the X minimum and X maximum. So that was -5. Arrow down to the X maximum, which is a +5 they gave us. Now the next two numbers are the Y min and the Y max, which was -30 for the Y minimum. So I would put in a -30. Then they had 70 for the Y max. Now, we got our window set exactly how they said set it. So go click that graph button and let's see which one we get. All right, so see how I got a couple clicks here. It's going in between the two clicks. So let's see if we can pick one. So y'all, let me move this out of my way real quick. So actually, to me, it does look like, let me get my eyes back on it again. Yeah, so it's right at that click on that line. So let's pick that one. Which means y'all went with which one? Oh, where'd my chat go? All right, I see it lighting up now. All right, so let me zoom these out more. You get a good picture of that. I'm going to zoom this one out. So let me show you the difference. You see this one over here? It's going in between the -1 or the -2 marks on that y-axis. This one over here is above the y-axis, okay? So when you look at my calculator, this one is above that first mark. So on that one, I would go back here and pick that C probably. Okay, so this one over here is going, it looks like these are marked in 20s, I would think, 20, 40, and so on. So since that one's a little above it, that would be 17. This one's probably around 30 or so, -30. But y'all, how about this? That was a really tricky one. So if you get flustered with it, email me. I can override that problem, okay? All righty, so I was mainly wanting y'all to see how they're going to be tricky on that one. So remind y'all, test 2 is due Sunday night at midnight. I sent a video after y'all's class Tuesday of the review and a bonus, okay? So if you do the bonus, you can text it back to me at my number or email me, screenshots or whatever, okay? That's 5 points on the test. In this class is like half a letter grade on that test, okay? So it'll turn a 100 into a 105, and turn a 70 into a 75, and so on. And they're not that bad to do, okay? All righty, y'all. Looks like that's going to be it for tonight. So any questions on what we learned? All right, let me stop.